Our next lesson is on indirect measurements. So that's using shadows and figures to find different measures. It's kind of a cool, unique unit. What is indirect measurement? Indirect measurement allows you to use the properties of similar triangles to find measures that are difficult to measure directly. So either they're too large or too tall. So for example, trying to find how tall a statue is, how tall a tree is, how tall the basketball hoop is. You can use your shadow to find heights of things you can't measure with a ruler, basically. So they use what they call shadow reckoning. So two objects and their shadows form two sides of a similar triangles. So, for example, in this picture, the height of this building would be one side. Okay? If you use the shadow it creates, you can connect it. So here's the height of the building makes the one side. Okay, how long the shadow is will create that. From the end of the shadow, you can put it up to the building. It makes a triangle. It's a kind of unique, funky thing that mathematicians came up with. So let's take a look at an example. A basketball hoop in Miguel's backyard casts a shadow that is 8 feet long. Okay, it takes a shadow that's 8 feet long. At the same time, Miguel casts a shadow that is 4.5 feet long. If Miguel is 5.5 feet tall, they want to know how tall is the basketball hoop. Okay, so you can use this by solving proportions. We have similar triangles, so we learned about similar triangles. You can make proportions with the corresponding sides. So there's two ways you can do this. You can either compare height to height, shadow to shadow, or you could make one proportion for the basketball hoop, one proportion for Miguel, which is the way I'm going to do. Okay, we don't know how tall the basketball hoop is, but we know it casts an 8 feet shadow. Okay, so that's for the hoop. Now we're going to compare it to Miguel. Okay, we know he's 5.5 feet tall, and his shadow is 4.5. So to solve for x, we need to cross multiply. So we have 8 times 5.5 equals 4.5 times x. So 8 times 5.5 is 44, so that equals 4.5x. Divide to get x alone. Run it out of space here. So x would then equal about 9.7 feet. So they're saying the basketball hoop is about 9.7 feet because the shadow's 8 feet long, and we compared it to Miguel. It's kind of tricky, but kind of fun at the same time. Let's take a look at another example. The lead statue of the Korean War Memorial in Washington, D.C. casts a 43.5-inch shadow. Okay, that's right here. Okay, at the same time, a nearby Taurus, which is the boy, casts a shadow that is 32 inches. The Taurus is 64. The boy is the Taurus, is 64 inches tall. They want to know how tall the statue is. Okay, so we need to find the statue's height. So we're going to set up a proportion comparing the Taurus to the statue. Okay, so we're going to do the statue, and then we're going to do the boy. So we do not know how tall the statue is, but we know his shadow is 43.5. Okay, we know how tall the boy is, and we know how long his shadow is. Okay, so I'm comparing height to shadow, height to shadow. You got to set them up in that way. Okay, now we have a proportion. We know we need to cross multiply. Okay, get out your calculators. This is some pretty big numbers. We have 32 times h is 32h equals 43.5 times 64, which is 2,784. We need to get h alone, so if we divide it by 32, the height of the statue will be 87 feet, or not feet, inches tall. Okay, so if you want to ever know how tall a statue is, you can use what they call shadow reckoning. Take your height and your shadow, take the statue's shadow to find the height. It's a unique way that mathematicians found out how to figure out how things are tall, or how tall things are, because they usually don't have a ruler that measures that high, or they can't climb up there and measure it. We'll be doing more examples in class tomorrow.